Day 20 video for Monday, April 27th. Quick little recap. What we've talked about is the multiplication rule for probabilities, and that is for the probability of two events A and B occurring. And it's simply the probability of A times the probability of B. That would be for independent events. The events A and B don't affect one another. The probability of A and B is the probability of A times the probability of B, given that A has occurred, for dependent events, which means that the A occurring affects the probability of B occurring. A quick example would be the probability of pulling a red card and a black card from a deck of cards, one after another. We can either do this with replacement or without replacement. So with replacement, it's going to be the probability of a red card. And since I'm replacing it, they're independent events because the deck of cards is back to the original. So it's going to be times the probability of a black card, which of course is going to be 13 reds. No, it's going to be 26 reds out of 52 and 26 blacks out of 52. So they each reduce down to 1/2. So my answer would be 1/4, 0.25, or 25%. So I can do the same thing, the probability of a red card and a black card without replacement. Now the second draw is definitely affected by the first draw. So I'm looking at the probability of red multiplied by now the probability of a black, given that a red has already occurred. Probability of red is still going to be 26 out of 52 times, now we don't have 52 cards, we only have 51, but the first card was red, not black, so there are still 26 black cards in the deck. So the 26 is going to be 1 out of 2, and the 26 over 51 doesn't reduce, but I can take the 2 here into the 26 and make it 13 out of 51, which is 0.2549. 2549 or 25.49%. All right, that's just a quick review of what we've done so far. Okay, so the problems that we're going to do today are going to involve or, not and. And implies that we're picking 2 cards, either with replacement or without replacement. We're spinning a spinner 2 times or something like that. It's two events occurring. The probability of picking a red or a face card is really just one draw. So we're not going to be using the addition rule for this. We're not going to be using the multiplication rule for this. We're going to be using the addition rule. So whenever it's an or, you're going to be using the addition rule for probability. And the first thing we need to decide, these 2 events, being a red card or a face card, you have one of 2 options. They will either be what's called mutually exclusive, which is also sometimes referred to as disjoint. And all it means is that these cannot occur at the same time. Or the second option is going to be that they are not mutually exclusive, which obviously then means that they can occur at the same time. So let's take a look at these two events. Can I be a red card and a face card at the same time? The answer is obviously yes. So therefore, these two events are not mutually exclusive. So the formula for two events that are not mutually exclusive would be the probability of A or B is going to equal the probability of A plus the probability of B. And no matter which one you got to think about, you're going to be subtracting that it's the probability of A and B at the same time. Now, if I'm not mutually exclusive and they can't happen at the same time, then this obviously would equal 0. So the formula for mutually exclusive is probability of A and B, which is just going to be the probability of A plus probability of B. It's really not a different formula. It's just we don't add on the minus the probability of A and B because it's going to be 0 because they cannot occur at the same time. So we've got the probability of a red card. Let's see here. Yeah, red or a face card, which is going to equal the probability of it being red plus the probability of it being a face card minus the probability that it is a red and a face card at the same time. So a red and a face card. So the probability of a red card is, that's half the deck, so that's going to be 26 out of 52. Plus the probability it's a face card. Well, there are three face cards per suit, 4 suits, so it's going to be 12 out of 52. But how many of those face cards are red? Well, half of them are red, so 3 per suit, 3 times 2 or 6 out of 52. So we're going to add the 26 and the 12 together, which is going to be 38 minus 6. So we're looking at 38 out of 52, which should reduce down to 8 over 13. Give me 0.6154 or 61.5%. Again, this is a fine final answer, and any one of these forms will work as long as just make sure this is completely reduced. Okay, next example I'm going to do is the probability of a heart or ace of spades. Well, the first thing we've got to look for is here we're dealing with an or, so we're not dealing with the multiplication, we're dealing with the addition rule. The heart and the ace of spades, are they mutually exclusive or not mutually exclusive? Can they occur at the same time? Can you be the heart and the ace of spades at the same time? And that answer is definitely no. So they are not mutually exclusive. So the addition rule is going to be the probability of a heart or the probability of the ace of spades is going to equal the probability of a heart plus the probability of the ace of spades. Now, it wouldn't make sense for me to minus off the probability of a heart and an ace of spades at the same time because that would be 0. All right, so quite simply, the probability of being a heart is going to be 13 out of 52 plus the probability of an ace of spades. There's only one of those, so that's 1 out of 52, which gives me 14 out of 52. So that's 7 out of 26, or 0.2692, or 26.92%. Okay, next we're going to look at a contingency chart, which I did last Thursday, which I took the video down because I forgot to do this day before, and there were some addition rules in there. We'll just put that up again tomorrow so it makes sense. But if you didn't see the video, it's pretty darn easy. This is going to be male or female, Democrat, Republican, or Independent out of a group of 100 total people we see here, and we're just going to fill in. A lot of times the chart's not going to be given to you. You just have to make a chart if you've got a couple things going on there. So this totals up to 46, and if this totals 42 and there's 25 here, that means I've got 17 here. Double check this, 31, 17, and 4. Yes, that should equal 52. 52 minus 100, that's going to give me 48 here, total males, but I got 15 and 25 there. That's going to be 40 of them, so that leaves 8 here. That should give me 12 here, 46, 42, 12, 1, everything works. Okay, so let's take a look at some probabilities. I want the probability that we are male or that we are Republican. So as soon as I see the word or, I know that I'm dealing with the addition rule, not the multiplication rule. I'm really picking one person. Is it this one or is it this one? Can you be male and Republican at the same time? Well, look at the male column. The male column is right here, and the row and the Republican column. So there are actually 25 that are male and Republican. So these are not mutually exclusive events. They can occur at the same time. Which means we have to take out the there we go. We have to take out the possibility that they are occurring at the same time. So my addition rule is going to be the probability that I'm male plus the probability that I'm Republican, but subtract out. Basically, you've got duplication of these two. Tough for me to say. So we got to take out the probability that I'm male and that I'm Republican at the same time, because they're. So we got 15 out of a total of 100, and no, we don't. What am I doing here? We're looking for the probability that we were male. Well, look at the male row. My computer is not cooperating with me this morning. All right, so we're looking for the probability of male. So we've got males totaling 48 out of 100 total. So this is a 48 out of 100. Plus Republicans. Well, look at the Republican column. We've got a total of 42 Republicans, and that's out of 100 total also. Minus off now, where are they Republican and male? Again, where the row and the column cross, I have 25 male Republicans that I need to subtract off of here. So you add the 48, the 52, and subtract off the 25. I think you're coming up with 65 out of 100. As soon as I have that, I can go right to 65%, or my 0.65. But we need to reduce this always, and that would come down to 13 out of 20. Now we're going to deal with the same contingency table here. Let's just take a look and see if the probability of a female and a Republican. Well, probability of female and Republican is one event. So we're not going to be multiplying anything together. There's no or, so we're not going to be adding anything together. We just want to pick one person and see, are they female and Republican at the same time? Just like we did for the male and Republican, the female and Republican is just going to be probability of a female and a Republican is simply just going to be 17 out of 100.